Where does it come from? Magnetic fields originate as a result of electronic spin, which creates an attractive force between other objects with mass. In other words, magnetism can be described as the pulling force created due to moving electrons. Electromagnetic magnets are created by running an electrical charge through a material in order to induce a magnetic field to form. Permanent magnets are always magnetized and have their magnetic domains aligned regardless of whether or not there is an electrical current present. Electron flow versus conventional current. Electron flow is always the opposite direction to conventional current flow. The electric field direction within a circuit is by definition the direction that positive test charges are pushed. Thus, these negatively charged electrons move in the direction opposite the electric field. Conventional current flows from the positive end of the battery to the negative end, and vice versa for electronic flow. These particles moving are charged electrons, meaning that they are also enacting a magnetic field/force on any matter surrounding it. What is the difference between a permanent and temporary magnet? Temporary magnets are usually made of a soft iron that is easy to magnetize. However, temporary magnets lose most of their magnetic properties when the magnetizing cause is discontinued. Examples of such include an iron nail. When hooked up to a battery to create a solenoid as such, the magnetic domains of the nail will align temporarily, but as soon as the battery's electronic flow stops, it will cease. Permanent magnets are usually a lot more difficult to magnetize, but they remain magnetized for longer periods of time. Permanent magnets are magnetized by using a ferromagnetic material, such as iron, and wrapping it in a solenoid in order to align its magnetic domains. A device such as a motor, on the left, also uses permanent magnets through a solenoid in order to spin the motor around. What is a ferromagnetic material? What is it? Ferromagnetic materials have this property of non-aligned magnetic dipoles with spontaneous orientation. These dipoles can become aligned if exposed to a magnetic field, which will align the magnetic dipoles of the element, typically a metal, with that of the magnetic material. Examples of ferromagnetic materials include iron, cobalt, nickel, magnetite, dysprosium, gadolinium, and aurite. The diagram on the right shows how it can get magnetized. How do magnetic and ferromagnetic materials react? The attraction between a magnetic material and a ferromagnetic material exists because the magnetic material exerts a force to align the ferromagnetic material's individual dipoles, which creates an opposite magnetic dipole in the ferromagnetic material, which attracts to the initial magnetic material.
Created using Powtoon.